perpetuate a digital divide in some portions of the population, not only in developing countries, but even in the United States, whether, I mean, this is somewhat of a tangential issue, but it would be interesting to see whether there are any technological implications to the perpetration of the technological divide. Big questions. I don't hope that we're going to be addressing. Each speaker has 15 minutes, but hopefully we'll be touching at least tangentially on some of them. And with that, let me hand it out to Ivy Schultz. I'm not going to introduce each of the speakers because you have the backgrounds in the handout material, and we're not going to misuse time to talk about their works. Ivy.
Thanks, Ronald. I'm going to start by giving you some of our research background. Before I start, I actually want to say thank you to Bob Atkinson. I've been working with him since 2009, and I've definitely learned a lot. So, in 2009, the FCC CITI to assess current and forecast broadband network deployments as part of the National Broadband Task Force. We use sources that were basically public information and journal reports. The FCC asked that we focus on 3 areas, and their focus was on end user infrastructure. So we're continuing with that focus. We looked at a summary of the announced plans, a comparison of their actual performance versus what they said they would do, and some future projections. So we did a second edition in 2011. Now we're editing a third edition. With some focus on video.
Well, it's there. It's in white.
White?
The
White on
video
white?
streaming HD is the huge number.
It's like iOS 7.
It's still digital.
So what you can't see with video streaming is way higher than everything else. It's showing on this screen.
Slides at 11. We'll get them by 11.
Anyway, we already talked about video and broad adoption. There could be even higher demand for speed with video applications, and even more with 3D TV. So here's a view of gigabits used per month by TV viewers. If they had 100% high-bit delivery of HDTV, they would use 8 times the average of internet use in 2011. The top quintile uses more. If they were watching HD, roughly 1,200 gigs per month. And if the person had 14 TVs, that would be a lot more. The dotted line represents a data cap of 150 gigs per month. So obviously TV viewers. So here's a view of gigabits used per month by TV viewers. Again, this is not a surprise to you that video is also driving mobile broadband use. Here, Genbank has real-time entertainment at 50% now, and in 2018 it's expected to reach 62%. This is a graph from the National Broadband Map, and shows basically that broadband service is basically ubiquitous and available in some form across the U.S. This graph is not about adoption, which is significantly less, or about actual usage at indicated speeds. So currently most of the country has access to about 10 megabits per second, and while some have, while 95% has access to speeds greater than 3, even more have access taking the definition of 760. adoption for wireline broadband. Analysts are estimating, that's loud?
No.
Okay, about 70% for 2013 and no increases after that for wireline. The delta between the two lines has basically been constant. Future change is not likely with greater adoption of wireline, and that's most likely due to the adoption of wireless. So I hope you can see this, but there's a very big gap as you get higher speeds needed for video when you get to rural areas. Density is a large factor in service providers' ability to provide high-speed internet, and the cost per subscriber in dense urban areas is generally much less than the cost of providing to rural customers, particularly for wireline. As wireless tech improves, it could offer a solution bridging the gap and serving more rural areas. What you can see in this graph, well, you hopefully can see it, is that the percent difference in rural broadband access increases a lot with speed. There's an exception in very high speeds where some rural telephone companies have installed fiber to the home. So according to the U.S. Census, approximately 60 million Americans live in rural areas, and that's 19% of the population. So here's the core issue. If the existing broadband infrastructure is generally capable of supporting HD TV streaming, but if cloud TV requires ultra broadband, will the existing and near-term infrastructure be capable? So a couple days ago, Netflix's CEO said that it would be. He said that consumers would need about 15 megabits per second, and that with a 50 megabit connection you'd be fine. He doesn't believe that there would be any problem with 4K streaming buckling networks, given that it's only a few people early on. Of course, there's a difference between real 4K and marketed 4K, and there'll be a lot of compression from the broad video to the viewer. So if the adoption of 4K exceeds the normal network upgrade rate, there could be a problem. The chief issue also may be financial. How much more will consumers be willing to pay for higher speeds? Will network operators apply data caps? And will content providers also pay? So the more money to be made by network operators from supporting 4K, the more enthusiastic they'd be to stay ahead of demand. As far as the telcos, ultra broadband goes, it's not ubiquitous. I'll probably just read over this briefly, but Fios has 18 million homes. AT&T Zubers has a new tier that's in 40 markets. The rural telcos, from a recent survey, said that 40% of their customers have speeds greater than 10. They are increasing the number of customers with fiber to the home and fiber to the node. However, 90% of those surveys cited cost as a barrier to fiber deployment. Here are some wireless speeds. According to carriers, there'll be 200 million people with LTE in the US by the end of 2013. Then for LTE Advanced, there are a number of steps necessary to achieve a full LTE Advanced network. Should probably put this on. We know that cable is basically ubiquitous, and DOCSIS 3.1 is coming. The initial deployments will be in 2015 and 2016, with shared speeds of 10 gigabits down. Cable Labs expects that 3.1 will satisfy user requirements for the next 10 years. It's also expected that the price delta between 3.1 and 3.0 will be much less than it was from DOCSIS 2 to DOCSIS 3. So that should allow operators to migrate to 3.1 more rapidly and more economically. Then there's Google Fiber, which has, of course, been in the news. You've all seen this. They launched in July in the Kansas City Metro. Analysts estimated that Google will invest $84 million to pass 150,000 homes, with estimates for a per home range of $564 to $700. Of course, passing 20 million homes or the whole country would cost a lot more. It would be $10 to $15 billion in many, many years. The peripheral benefits, however, are many. There's a lot of incumbents responding to higher speeds at comparable prices, and the networks are definitely threatening to incumbents because they really push the speed to price ratio. This list demonstrates that gigabit services are not just in large markets. There's 22 currently in the US. Some gigabit may be wireless as well. There's an announcement in Blacksburg, Virginia that they were initiating a public gigabit wireless service. That's all very new. So it's clear that within the next 3 years, the transmission rates offered by companies will grow significantly. The majority of carriers have said that they'll be offering more than 100 megabits per second by 2015. And Adtran, who initially presented this, said that by now that number would be higher than 39%. So this is only a 4-year picture, but we generally think that speed increases and capital spending seem to correlate. Consumers are willing to pay more, willing to pay a premium for higher speeds, especially when they can get clear benefit from higher speeds, such as uninterrupted video. This has been a large factor in CapEx. So this compares the total industry CapEx and the total broadband CapEx, and what you can see here is that the percentage devoted to broadband CapEx is expected to continually increase for the next 5 years as companies continue to devote a greater percentage of their total expenditures towards broadband and away from voice. So traditional telephone companies are transitioning as quickly as they can from the public switch telephone network to an all IP architecture. So very little is being invested in telephone infrastructure. The CapEx devoted to broadband in all sectors in 2018 is estimated to grow to almost $55 billion, or 79% of the total. And even looking at the individual sectors, broadband CapEx is basically flat for the next few years, with no spikes that have accompanied the rollout of new technologies on a wide scale. So most of the basic infrastructure deployments have been completed or are well underway, and you shouldn't expect the announcement of an entirely new nationwide rollout. But CapEx for maintenance, new customer acquisition, network extensions, and capacity upgrades leave spending at a relatively high level. Service providers will spend $40 to $50 billion a year for broadband upgrades and improvements. That's LTE Advanced and DOCSIS 3.0. This chart estimates $232 billion will be spent on broadband across the major service providers in the next 5 years. So our conclusions are basically that $1 trillion was invested in the initial broadband rollout by service providers and by consumers. There'll probably be another $1 trillion decade through steady upgrades and improvements. And the CapEx forecasts show that there's no radical changes. Basically, what you see is what you get. It's business as usual with no great inflection for something new and different, but also significant annual investment in upgrades. So the current infrastructure will support 4K TV in modest numbers, but not with widespread adoption. Supporting cloud TV with broadband or ubiquitous 4K may be about business strategies and public policies more than just infrastructure capability. So we had 3 questions to pose. Hopefully we can figure all this out by the end of the afternoon with all the great minds in here. Will it be a la carte video versus multi-channel streaming? Will there be bandwidth caps? Will there be a 2-sided market or network neutrality? Thank you.
One of the issues that we do might raise discuss is the aggregate CapEx numbers.
Can't hear you.
Well, we can't hear it because of the thing that's
It works, it just, I potted it down so you don't get that caramel. His sound. like
Okay,
this.
no, so the aggregate CapEx numbers are obviously, these are national numbers, so you see the state by state, because the state by state shows wide variances between regions of the country, and it might emphasize the point that you mentioned before about digital divide, and we can address that when we get to the discussion. The next one is Howard Onoff, and please, go ahead.
Thank you. Can everybody hear me?
It's hard.
I guess you wouldn't be telling me if you couldn't hear me, but okay. All right, I'm going to, my presentation may sound like a bit of a refugee from this morning's panel. I wasn't able to be here this morning, but in my definition of focusing on the impact of cloud TV. Now for a break.
Now for something completely different.
Okay, so I'm going to look at the implications for cloud TV for what I would refer to as business infrastructure, and I want to pick up actually interesting a remark that Ellie made at lunch, which was the importance of video in terms of driving the funding of broadband and technology infrastructure, that the popularity, the enduring popularity of video in its various shapes and sizes is really a critical driver for the business success of broadband as well as broader technology infrastructure. And so what I want to focus on are sort of the implications for four parts of the video business infrastructure. The first being content producers, second being content distributors. Those two collectively essentially are the people who get paid in one shape, form, or another, generally for the creation, distribution, exploitation of video content. And then the other two critical actors are brands or advertisers and consumers. And those are the two people who more or less have got to be the funders of this, either brands that are trying to piggyback on content in one shape or another to reach consumers and will help fund the development and distribution of content, or consumers who are going to pay directly through either subscriber fees, through micro payments to purchase individual content, a la iTunes, or through some form of a freemium type of model. And all of these groups, particularly on the business side, obviously, but consumers as well, are going through enormous change right now. And it reminds me of a conversation I had recently with a very senior executive in the media business, and I said to him, you know, there's so much going on in your business, in your company, kind of, you know, so many convulsive changes. How do you deal with this? You know, how do you sleep nowadays? He said, sleep like a baby. I said, really? He said, yeah. I fall asleep as soon as my head hits the pillow, and I wake up in the middle of the night screaming. So we all have our different ways of dealing with change, but in fact, my view of this is maybe a bit counter to the typical narrative, which is that I believe in the theory of evolution. And for Stephen Conway, I'm sorry, another political reference. So I'm not a Tea Party guy, therefore I believe in evolution. But I don't. But in this case, it's not versus creationism; it's versus revolution. And I think that if you look at the development of the video business market, despite all of the convulsive changes in technology, it's actually interesting. Change tends to be evolutionary and not revolutionary with respect to much of the business. And it reminds me of something somebody I know once said a couple of years ago, which is the technology that's going to completely change the media business model is always 2 years away. However, it's never 2 consecutive years. So change will come, but it's not quite as fast as we all may sometimes hear about through the media. So let me go down those sort of 4 groups that I had talked about, and try to make sure Bob doesn't yap going too long. First is the content producers, and I want to talk about the implications for the business model and talk about implications for the content itself. In terms of my overall view of this is, and not a revolutionary view, is that cloud TV is part of the system facilitating much more content to be consumed by many more individuals, on many more platforms, in many more geographies, and with proliferating means of paying and accessing that content. So I think if you are a owner of a content library, or a producer of content, or a distributor of video or TV content, there are enormously new opportunities available to you. And in several ways in terms of the business model. I look at the audience, and this is from a traditional, again, you may read so much about the end of television as we know it, and the destruction of the multi-channel video package and programming. But if you look into some specific examples of how the cloud is supplement or supporting that business, I think there's an interesting counter-narrative. So for example, how many people here are Breaking Bad fans? Okay, Breaking Bad, one of the great historic events coming up, which is the end of Breaking Bad coming up this Sunday. It's gotten a lot of publicity. I was at an advertising week conference yesterday with the CEO of AMC Networks, which is both the network that distributes Breaking Bad as well as the producer owner of the programming, in that case a content producer and distributor, noted that more than half of Breaking Bad's viewers, and they are now looking at 6+ million on the Sunday night viewing alone, which is an extraordinary number, by the way, in the history of cable. Used to be only broadcasters who get that number. But more than half came to the series Breaking Bad through an on-demand, including a cloud TV platform, which is really pretty incredible. And what Breaking Bad has done in their business model is and I'll say it anecdotally, I came to that show through Netflix, and came to that show as literally, half of the audience in one fashion or another came to it, and that facilitated a later live, or in the advertising world, live plus 7 days, which gets measured for advertising purposes, but it was not competing with cloud TV in that case. It was supported. And I think increasingly what you'll find is, from a business perspective, is the successful traditional or first media content is going to have as a critical component what is your cloud TV strategy. Much as we saw the motion picture industry spend years living off of DVD revenue and international distribution. If you didn't have those as 2 key components, and particularly international still all the more today, if those 2 pieces were not a critical part of your motion picture development strategy, that motion picture probably wasn't going to get made, never mind succeed financially. In terms of the content itself, what I would simply say is that cloud TV, by being an almost entirely, and I'll put live sports aside for a minute, almost entirely an on-demand type of viewer experience, typically you're going to see a more engaged, more involved audience, willing to spend more time with complex story making, complex characters, because it's somebody that's made a choice rather than just sit down and whatever it is that's on at 9 o'clock on Wednesday night. They're invested in a longer relationship with content than has traditionally been available. For the content distributors, again, I think that what you're going to see in the content distribution world, which is already happening, I think will be more of, is that rather than the bundle will disappear in 3 years and just fall off a cliff, what I suspect you'll see is more and more, and I think a demand for innovation in terms of how the package is constituted, how it's delivered, how it is, and how it's marketed to consumers. So if you look at small announcement in the last couple of weeks, a company named Ardio, which is packaging, which is packaged audio on-demand content, is now going to be providing packaged content of audio and video. We're the people best sort of, at a starting point to package that in an attractive way to the consumer, the people that have had the long-standing monthly subscriber relationship, whether it's a Comcast, Cablevision, Charter, DirecTV, etc. And I suspect you will see more and more of the joint venture, joint marketing opportunities may actually lead to an M&A ultimately down the road as well, but looking at partnerships between a Spotify and a Comcast, between Hulu and DirecTV, etc. So I think those are the kind of what you have a need for amongst the distributors is what can I do? And it's not just distributors, it's the programming networks as well. How do I maintain the value proposition for that packaging programming to the greatest extent possible? And adding more content, not at a higher price necessarily. In terms of where that pricing gets sliced up, that's obviously going to change. But the kind of, the notion of being a subscriber and getting a large bundle of content as opposed to only on an a la carte on-demand basis, I think remains a very powerful value proposition for consumers. Nielsen last year noted that, and it might, nobody in this room might fit that average, but that the average American still watches over 5 hours of television per day. Think about it. Now, everybody that I ever seem to talk to, it's about, if I believe them, it's about 2 minutes a day. So somewhere in the Midwest, there is a lot of people watching 27 hours a day of television to get those numbers up. But the fact is that there are a lot of people that bundle still remains in terms of their lives. I think Elliot mentioned this before. Not necessarily only people at the top of the income chain that still value the mass of content. In terms of advertisers, very quickly I would note that advertisers are searching for solutions, although the television multi-channel video package is not gone. I don't see it going away in the next couple of years. The stresses for the advertiser are very real and very obvious. It's traditional use of print and traditional reliance on the 30-second spot. Still a $66 billion television market, but it's a market in which people's attention is increasingly threatened. So I think you will see advertisers at the forefront of innovation in the cloud TV world, and not simply as passive purchasers of advertising, but think of them as giant VCs. We're going to take, I think, a more aggressive, earlier stage and deeply pocketed investment in the development of content, of technology, and I think perhaps even in terms of networks. So I think that will be an interesting development to see. For the consumer, the consumer, I think it reminds me, and I'll just close with sort of an interesting quote I heard. Jeff Bezos was asked recently, what questions do you get asked most often? He said, it's what's going to change in the next 10 years. He said, the question I get asked least is, what's going to stay the same in the next 10 years? And if you have a business that will support things that we know are going to endure, that's a pretty powerful support for your business. And people, going back to Shakespeare, going back to the Greeks, going back to the caves and the drawings, people like stories, people like comedies, people like dramas, people like sports, people like news. However that gets delivered to them, the basis of that, I think, will endure and will remain critical to the entire ecosystem. Thank you.
So, yeah, Howard warned us that he was going to be a refugee of the morning, so he talked more about business models and applications and infrastructure, but nevertheless, interesting. I'm still struggling with the definitional issue, and I think I'm going to what Adam said. What is it that we get into the universe of cloud? Do we go all the way to 4K? Or do we stay till the end of whatever streaming we're getting right now? and partly was addressed by the section that maybe with 15 meg, we're fine, as the CEO actually said. So at some point in time, we will have to talk about that as well.
So what is it?
We return. When Bob, will we deal with
Too many wires.
I thought we were in a wireless world.
Why don't we keep talking until that's their setup, because I'm gonna go through a similar process with
So, yeah, so actually, I was interested, Howard actually told us with advertisers that we're going to fast forward and go back to the Alcoa Theater, where the advertiser, no, seriously,
Texaco Star Theater.
Texaco Star Theater, so it's where the advertiser takes control of producing the content, right? And it's not going to be the, necessarily the packager that's going to be the producer, it's going to be or the whole thing. So this is. So it must have come.
I'm just gonna stand here.
Okay, there you go. Okay, so I'm actually going to talk about what the session was about, which is, what's the impact of cloud and video on networks and network requirements. And I want to talk about networks fit for purpose. The data are based on our visual networking index study, our cloud index study. Ellie this morning pointed out that we forecast that for global IP traffic, the 5-year forecast is a compounded annual growth rate of 23% per year. For mobile, it's going to grow at a 66% CAGR. But what's interesting is rubber band? Try rubber band. Okay, we'll go with that. Okay. I just got to do better than that. But let's just unpack this a little bit. So for mobile, right, and we heard today from at lunch from Hamadoun that the way people around the world, not global data, not just US data, the way people around the world are going to be connected, it's going to be mobile broadband. Right? So let's just look at mobile, for example. And what we're forecasting is that for mobile, on an average global basis, right, it's going 66% CAGR, but 66% of the traffic over mobile will be video. Right? So, and video does not just mean linear television. It's not long form. It's not just what we've been, hearing about. It is short form video, long form video, and as you'll see, video to the TV, video to the PC, video to the smartphone, video to the tablet, two-way video. It's going to be Skype video. It's going to be high-end telepresence. It's going to be FaceTime. Video includes a lot of categories of video, only some of which is television as we know it today. Take video, right, and we can talk about, and already Ellie, I think, talked about this earlier this morning, the difference between IP video and internet video. IP video being a subset of, or internet video being a sort of subset of the IP, but the IP video basically being the managed IP video. And there, what we're seeing is globally, right? For IP, this is fixed and mobile. Globally, the average is 73% of IP traffic will be video. That includes internet video and managed IP video. Globally, it's going to be internet video about 52% and managed IP video 21%. And what you'll see, I'm going to now show you by region of the world. The rough numbers are the same, although you'll see the US, it's actually higher for total. But the relationship between the, here a clicker with yes, there it is, an infrared, actually press the green button, so it's actually not infragreen, not infrared, that the difference between the internet video and the managed IP video changes by region based upon the current networks, operators, and then I'm going to talk about content delivery networks, CDNs, and some other things. In the US, we're looking at 81%, we're forecasting by 2017, 81% of the traffic across the internet is going to be video. With a huge amount of it being managed video, managed IP, 33% of the total, About 47% is going to be the internet video. Sorry, 81% of the traffic is going to be video. So the question, Ellie, is will video have an impact on our networks? You bet. Well, then the question is, will the networks be able to support? I'll come back, Bob. Let me finish. We'll come back to the question. Now let's take a look at some other regions. Western Europe, right? 72%, but the relationship between internet video and managed IP is very different. Very different. CDNs in the US are much more highly developed. We also have CDN federations building up among the network operators, managed IP traffic, video for cable-like services, but delivered by IP instead of traditional cable. That's growing. The US market and networks and operators and content providers are way ahead of the rest of the world on that, but that's what the world is going to look like. Asia Pacific, very little managed traffic. The total is going to be 66%, very little is going to be, I'm sorry, managed. LATAM, it's even less managed, right? More of it's going to be 74%, but the vast majority is going to be over the open internet, and less of it's going to be managed, and less of it's going to be through CDNs. Implications for the operators, the carriers, the networks in LATAM. Middle East, Africa looks more like LATAM, right? With less of it being managed. So the challenges are going to be different on how you manage the networks, and the challenges on the networks, investment network architectures, and how the networks are managed are going to be different by region of the world. Briefly on devices, two things. One, left column, last year. You'll notice that the devices, not all devices are created equal. The biggest differentiator in this is data consumption by device on average per month. It's really the processor speed and the resolution of the display. That's what drives the data consumption that's the major variable on the device. So we look at this, we see, PCs are, consuming on average when they're, almost 19 gigabytes per month. Internet-enabled TVs, almost 6. Tablets, smartphones. But let's just go forward 5 years. With the, is that the 12 minutes or 15? That's the 12. Okay, thank you. So what you'll see is that in 5 years, right, the tablet and the internet TV, and again, the internet TV is more display, less processing, and that's why that figure. They're going to look like today's PCs in terms of the data consumption, and again, that's being driven by video. Types of devices. If you look at the types of devices as opposed to the data over the devices, you're seeing that the types of devices, just in terms of the numbers, a lot of machine to machine, but they're not going to carry a lot. Smartphones, non-smartphones, because of the 2G phones that are still prevalent in China and India. But look at the consumption by device. Right? You're looking at PCs accounting for half the traffic. Televisions, this is IP traffic, internet traffic. Televisions are going to account for a quarter of the traffic, and then you have smartphones and tablets, each with about roughly, let's call it, 10 or 11. Very different profiles, and again, this is what we're seeing in terms of video driving internet data consumption. This is internet traffic. Previous was sort of IP traffic. And it's even more so in terms of PCs for 60% and TVs for 7%. Difference, the IPTV managed video is going to the TV. Right? The internet video that's not managed is going to the PC and the smartphone. That's why when you look at the percentage of IP video, TVs for such a higher percentage. Interestingly, by region, Brazil, China, and India. So the question is, how is this going to get to the device, right? So there's this question about, right, you know, gaming consoles today account for about a little more than half, right? That's the video that's going through the Xbox, right, and the PlayStation. That's going to decline to about 33%. It's still going to be a lot because of the growth. But look at what happens to either set-top boxes provided by service providers, 70% to 16%, and set-top boxes that are not provided by the service provider, right? That's going from 19% up to 31%. So set-top boxes are going to basically have about half of the traffic, and the gaming consoles are going to decline. By different countries, it's different profiles in terms of the set-top boxes by service providers, non-service providers, connected TVs, gaming consoles, and so on. There are a couple of other trends that we've seen this year. Every time we do this, there's always what I call my ahas, things that surprise me. Video is the big driver and the big message out of this year's data is what we are seeing is that we really do have a prime time on the internet, and it's driven by video. And what you look is in terms of around the world, what we're forecasting is that the peak to average, right? Peak to average ratio is growing. In fact, busy hour is growing faster than the average. Average doesn't work on the networks. If you're worried about the networks and can the networks support the traffic, don't look at average. Prime time on the internet is 9 p.m. to 1 a.m. instead of prime time in television, 7 or 8 to 10 or 11. Colleagues in Japan told me that, in fact, what explains that in the 11 to 1 a.m. is what, I forget who it was who had the 3 S's. All right, who was the first one. The other thing in terms of network architecture, turns out metro is growing a lot faster than long haul. Long haul is doing just fine, inner city. It's metro. Metro, including access, is growing much faster than the long haul. Why? Caching. Right? If I'm caching locally, it doesn't drive more long-haul traffic, it's driving metro traffic. And supporting that is what we see is the growth in CDNs, content delivery networks, not just by Akamai and other independent CDNs, but network operator CDNs. So what we're seeing is, in fact, with video, globally, we're forecasting that almost 2/3 of the internet video traffic will be over CDNs. This is again reflecting managed IP video networks. We're forecasting 84% of the traffic across the nets are going to be cloud-based by 2017. Makes sense. All the videos in the cloud, whether it's your iTunes app, Netflix, Amazon Prime, Hulu, it's all cloud-based, and it's being delivered through CDNs. So 84% of mobile data is going to be cloud-based. So what do we mean by cloud? Since Bob is going to nail me because I've already run out of time, we actually define, people talk about cloud, but they never tell you what it means. So we've actually looked at different cloud applications, basic, intermediate, and advanced, and what kind of network is needed to support cloud services for each one of these. It turns out that most people, when you're accessing a cloud app, don't access one at a time. So the more relevant number are the concurrent cloud applications. You're doing multiple things at once, drawing from the cloud. So if you're looking at some basic video streaming at low definition, a basic cloud app can support that. A network to support basic cloud can support that. Concurrently, a couple of megabits down, half a megabit up. The variable and the gating factor between Basic, intermediate, advanced is latency. People don't talk about latency. They tend to talk about bandwidth. Multiple dimensions of broadband. Intermediate is going to require latency above 160 milliseconds, that's okay. You're going to need latency below 160 milliseconds, and 5 to 7 meg down, 2.5 meg up. When you're talking about some basic gaming, you're getting to the business applications here, basic video conferencing, advanced social networking, some HD video streaming. But when you're looking at some of the more advanced cloud apps for business, including interactive video, including high definition, things like telepresence, industrial design, CAD/CAM, etc. For those advanced, you need latency of less than 100 milliseconds, and you're looking at a couple of, at least 20 meg down, 9 to 10 meg up. We actually have network performance statistics. So on fixed, right? So it's if it's red, it's the color scheme here is about latency. The vertical is upload, horizontal is download, and you can look at where different countries are on the performance characteristics. If you're going to need 20 meg down, or 15 to 20 meg down, and 7 meg up, you're looking at these countries that can support advanced cloud applications. These countries concurrently, these countries can support some, but cannot support the full complement of concurrent. Most people will be connecting around the world through their wireless connection. And when we take a look at wireless, nobody, except for Hungary on latency, and that's kind of an anomaly, can support on latency advanced cloud apps, and on bandwidth, they can't support more than one. And a lot of countries, including the US, currently have latency so high, they cannot support even one advanced cloud application. They can't even support an intermediate cloud application. Conclusions, video and cloud are driving demand. More devices, and those devices are going to become more powerful very quickly. Advanced cloud apps need advanced networks with low latency. Networks are becoming heterogeneous, and what I mean by that, it's going to be small cell, it's going to be macro cell, and the point earlier today I just made is you're going to have fiber backhaul. I joke, people talk about mobile networks, there is no such thing. Networks are not mobile, they don't move, I move. It's going to have to be fiber to the tower or it's not going to work. We need fiber for that backhaul, and we need to be able to manage networks fit for purpose. Thanks.
Obviously you saw in this characterization that they were talking about consumer cloud apps. We're talking about 7 meg, and at 7 meg, some people are thinking about 50 meg, and fit for purpose says that maybe we're fine with some type of consumer-based apps. It raises the issue whether we should look at countries in the aggregate or look at the zones of economic development where industries really are and deliver that speed where businesses are, and the rest will be even less. The next speaker will please tell us.
So you asked a question while Gary's hooking up about energy and cloud. There's another part of energy when you're looking at the developing world, and that is how do we power the cell tower in the rural areas? How do we power the devices that people have in their homes or villages? So there's power at the user end and power at the data center end. And so power becomes a real issue.
Which is what my smartphones are more appropriate.
Or the low power tablets that we're seeing from online. Yeah, the latency. Except in one-way downloading, but that's not, the latency is still going to come.
It should.
Set? Go.
Okay, thank you. So I'm honored to be invited. And so the question of the day is, can broadband networks handle cloud-based video media? Yes. Any questions? So I'm going to try to talk fast, use the Doppler effect, which is the tendency of stupid ideas to seem smart if they come at you quickly. Since we're running late, and also people tend to use their experimental cycles to multitask and reduce attention, so I'll try to give all your cycles. Anyway, so I'll also give two demos. Actually, only one. See that DHCP is working. Firstly, raise your hand if you're a network operator. And if you're a technology vendor. And if you've heard me speak before. Two. Okay. Have any of you heard of active video networks? Okay. And have you heard of OnLive, which is a cloud-based gaming service? Okay. You do more. And raise my hand if you believe in encyclopedias. Full disclosure, on most days I put my money where my mouth is, and my money is. And I invest in what I believe in. I'll be sharing some of those beliefs. I also believe in some things I don't invest in. So by me, I'm a venture capitalist who specializes in TV technology. So I invest a lot in cable TV vendors, which makes me a masochist. Making investments in the future requires attempting to predict the future, but predictions are hard, especially about the future. So the best way to predict the future is to invent it. Abe said, and I say the second best way is to finance the investments. So venture capital diversity ranges from the technological to the scatological. One of the deals I received, the lowering and lifting potency, and where one stands often depends where one sits. My investments in cloud-based video, at least the ones I'm going to talk about, are active video networks, of which I'm chairman, and its main product is named Cloud TV, and has been since 2009. It's a trademark term. And the other is OnLive, which I'm also chairman. So each are leaders in cloud-delivered interactive TV. OnLive delivers fast Twitch AAA games without having to have an expensive console at home. And Active Video delivers a wide range of applications. Cablevision is using it for interactive TV, games, advertising, etc. The games they offer are sort of casual games. Ziggo, a cable operator in the Netherlands of similar size to Cablevision, uses it for video on-demand menuing and something called catch-up TV and other things. And Charter announced their intention to use it to provide the electronic program guide, and basically to enable them to not upgrade their set-top boxes and to deliver all the services to their existing installed base of boxes. So both companies are similar in architecture, but they have some different specifics. But I think it's a huge paradigm shift. They're optimized for different purposes. Active videos, games are casual and free. Online is really high-end. So first, we're going to give two demos. The active video one was on a Roku box, which required Ethernet. The Ethernet wasn't offering an IP address, so instead, nor the OnLive box couldn't get it either. However, there's an OnLive client, which I can switch to. Runs on locally on my laptop. Here is so this is showing going back up. This is the sort of the main menu, and there's a bunch of choices. But I could go in and show playing any one game, but it's easier to go into this thing called the arena, where I can show you other people playing games over. Most of the users are playing it on a client such as this, which is basically what's happening. All the execution of this game is in the cloud, and the output is being encoded into video in real time and sent down. Keystrokes are sent up from whether it's a game controller or a keyboard or touchscreen for Android and iOS tablets. So all these games are executed in the cloud, encoded in HD video, and sent down the IP path to whatever device. Devices can include mobile tablets, it would be a little micro console, which actually sorry, I didn't realize I was attached. Yeah, it's still working. Okay. Put this on my belt. So this is a micro console. So this delivers the equivalent functionality of an Xbox or a other type of game console. When I say equivalent functionality, that is this plus the cloud delivers the equivalent functionality. Anyway, so if I were to just, as an example, go into any one game, let's see, this one. Yeah, this is actually via Wi-Fi, well, this actually isn't a very high-end game. So I don't really like first-person shooters, but this is it shows sort of more of the 3D graphical capability. But the point is that you don't need to have functionality in the home anymore. If you once the pipe is fast enough, then you have the freedom to decide where to put the CPU and graphics and all the expensive stuff. And if you have the choice, then of course you put it in the network. Why on earth would you put it in the home? So anyway, this is a really important paradigm shift. And there's a lot of talk about cloud this, cloud that, cloud TV, et cetera. The fundamental difference in both these architectures is that most of the cloud TV stuff you hear about, the idea is you take a computer-ish device, maybe a computer, maybe a set-top box with a browser, and then and in those other models, you still actually have a big CPU and memory graphics and all that running locally, and it has to do HTML5 today, HTML6 tomorrow. There's all sorts of issues around it. In this model, you have a very thin client. All it does is take keystrokes, or their equivalent, send it up to the cloud processes it quickly, quickly encodes that, and sends it back down. And as long as that round trip is sufficiently low latency, then you as a user can't really tell the difference. And
What is your latency requirement?
well, it varies by game. So firstly, the numbers you showed actually are higher latency than we are encountering. However, let me put it another way. When a user logs on, it checks the network to see which of our data centers has the lowest latency to it. And then it determines if it's fast enough to provide a good experience. For some fraction of users, it says basically your network's not good enough, and so turns it down. So, but we succeed with the majority of people who try. And this is only going to improve over time.
So this is 100 milliseconds?
The network latency we experience is less than that. The total latency round trip, include from pushing the button to seeing a change on the screen, typically exceeds that because there are many things in the path that add up to the latency budget. But some of them, for example, some TVs have a lot of latency just in the TV itself because of their post-processing of the signal. So you're trying to. So every device is different, and there are a lot of variables.
What do you need for the game? I mean, like for example, what's the range of latency requirement for different games?
I don't have I don't know off the top of my head. I mean, all I can say is that it also, even for a given game, it depends on what's the next best alternative to the user. So if you love this game, but you've got an antique computer and it won't otherwise play it, you're willing to put up with more lag than if you got the game on locally or in the cloud, and then it's sort of a more marginal decision as to which way you do it. So it depends on the circumstances, and to the extent that we deliver to tablets, you can't run these games on a tablet. So since there isn't an alternative, one would perhaps put up with more lag than otherwise. So anyway, it's the clients are free to download. 3 minutes.
Well, I had it up for 5 minutes.
Take out my time.
No, that's okay. I guess I should switch. I guess I should switch to my presentation. I only have 60 slides to get through. Okay, so I mentioned about talking faster. Well, I will. Yeah. So. Well, the So let me go really fast. So you know the cloud cyclone is the name of the novels in Silicon Valley. I'll skip the origins of the terms. You're going to be handing out, passing out these presentations, right? Yeah. So.
I'll be quick about it.
Okay, great. So, so Builder's Law, was this mentioned earlier today? Or
No.
are you familiar with it? Okay, so basically, you know, Moore's Law is the number of transistors per chip area doubling every 18 months. Builder's Law is the bandwidth grows at least 3 times faster than computer power. And so the trend since 1860 has been up and down, but it's mostly up lately. So another, also encoding is improving dramatically. The lowest line here is HEVC, high efficiency video coding. So an important conclusion is that once the network is fast enough, you have the freedom to relocate respective functions. I mentioned that before. So I was going to explain where out of the box comes from. The 9 dots problem to solve, and one has to go out of the box. I was let me whip through this. Let's do one-line solutions out of the box. So this explains the architectural stuff. So there's some pretty animations. So latency is also a function of the bandwidth. That's something that's not obvious, but basically it's independent of but correlated with the bandwidth. Typically, the faster the network, the lower the latency. Here's an SEC's data that's graph. So, but latency can often matter more than bandwidth. For example, the rendering of a web page. So if you have very low latency, then you can get a page to load in, say, 3 seconds, whereas with higher latency but similar bandwidth, it can take 10 to 30 seconds. This is the animation I referred to, taking the functionality of the game, moving it out into the cloud, and so online progressively peers with other networks, and it reduces the number of the hops. Originally, the company was founded to expecting to have to locate the processing in service providers' head edge. But they were able to take so much latency out of the system that we're actually out on third-party stuff without having to have any special arrangements. So public cloud, well, infrastructure as a service, platform as a service, software as a service, lots of other things as a service. Skip that. I mentioned to you about how this already, so I'll skip that also. There's a lot of false dichotomy thinking regarding cloud stuff. Humans often view alternatives as mutually exclusive when they're not, and so there are many ways to mix and match how much one does in the cloud, how much one does locally. It's not really an either/or. Humans tend to overestimate the level of simultaneous use for things that are intention-based, and so which inherently cloud systems are, and so that causes people to underappreciate what they can do and overestimate the level of CapEx necessary. So let's see what else. Another important thing that has been a problem for cloud-based systems is that Moore's Law is making powerful set-top boxes cheap. I remember the Vice President of Engineering of TCI about 20 years ago telling me that with the cost of CPU, with Moore's Law, the cost of CPUs and memory going to 0. Well, Zeno's paradox, which is everything having and having and having, and you never get there. It is far from 0. So obviously it's getting cheaper, but there are still many costs, like the cost of rolling a truck goes up, not down over time. Software integration, and the challenges to service providers are serving a diverse population of devices, from 15-year-old boxes to the present is a huge issue. So there are a couple policy questions. Is there a need to regulate latency? In other words, there are things an operator can do that will worsen it for third parties, the issues with fairness about things that an operator does to improve it for the network owner. there may need to be accurate disclosures of latency by service providers. I mean, just one little thing, not latency related, but if you go to speedtest.net, the operators all accelerate that function. And so, anyway, so then there's other policy question of the day. Can broadband networks handle cloud-based video media? Yes. So a little more detail on that. Hybrid fiber coax networks scale very well. There aren't major discontinuities needed. They don't need to get out of backbone to upgrade them. So there are no major discontinuities on the path to huge amounts of bandwidth. So a policy problem is that they are inherently natural monopolies. So the question is whether there will be enough competition. I think wireless probably will effectively, but it remains. So more things change. Change is inevitable. And Darwin said it's not the strongest of the species that survives, nor the most intelligent, but the one most responsive to change. So the cloud doesn't always deliver goodness. Here are some practical shields. But anyway, I hope this has had a positive impact. Thank you.
So, we certainly can multitask. We get just how much time do you have for questions?
20 minutes behind.
Hour, 15 minutes each time, that'll get it out here. Using all available options.
5 minutes.
5 minutes, 3 questions. Very short answer. Yeah, that's what I was thinking.
Short questions. No statements.
Yeah, just
Question.
no comments, yeah.
So we're talking about bandwidth and latency, and a bit on usage caps. What about usage caps, particularly in rural areas where it's much more wireless centric?
Usage caps, yeah.
I just want a clarification from Robert's presentation. Was Matt, if you could just explain the definition of what the managed video was again? I'm just not clear.
Usage cap managed videos, yeah.
AT&T Ubers.
Bob, your presentation is mostly driven by the technology, and Ivy's forecasts also were just looking at spending going forward.
Unless you add something like the economics, what are the costs? How are they going to change? And the last case that we just saw was a case of a device coming on the market where almost all the functionality is now in the cloud. And so the demand elasticity for his product is going to be very different than demand elasticity for a typical video product. That's going to change demand going ahead. Unless you accurately estimate that, your forecasts are way off.
Okay. Any other questions? Last
You
question
have to
over there?
do the economics.
Last question over there? Yeah?
Just great to see the attention to latency in the panel. Just curious if there are any examples of where latency is either regulated or standards have been designed in markets globally, if anyone's aware of that.
Is there a standard for latency?
Okay, so why don't we say 2 minutes per panelist if we feel that we need to address the question. We go left to right.
Yes.
So I don't know if somebody else does, any place that regulates latency at this point. I mean, there's some questions in. No, the reporting on latency, and in Europe there's some reporting for transparency purposes, but that's whether that's regulation or not. The forecast, so yeah, we always get the forecast questions, right? The forecasts don't work, we don't believe them. We go back and we've been doing this rolling forecast now for 7 years. It's a 5-year rolling forecast. We actually go back and check, and we report. So, for example, typically we just made a forecast. Sorry, we just actually had actual data for 2012. We went back and took a look at the forecast in 2008 for 2012. It was within 10%, and it was on the conservative side. Now, your question is, what happens if things change? The model we have is dynamic. It has to be. I pointed out this earlier. The question, how old is from Paul, how old is the iPad? Right, our forecast in 2011 didn't even include the iPad. I mean, you have to include tablets. And so as these things change, the model is updated. going forward in economics and demand. It's not just a technology forecast. It's based upon actual usage that we see in the networks, so it's usage. We work with the, methodologically, we also work with the device manufacturers and what they're forecasting in terms of their manufacturing, what the devices are. Happy to go into all of the deep dive on the methodology. It's a forecast, so it's not going to be perfect, but over the last 7 years, it turns out, when we go backwards and look at what did we predict and where was it, really good numbers, and we're really very confident.
But some of us would
On the
This is a tough room.
Oh, drinks at the end.
We have to get out of here.
Today's the day.
So make just a quick clarification on our forecast. It's based on what financial analysts are forecasting, and the work that we did was to try to figure out within those forecasts what is changing in broadband. So what we've done is adjust the level or the amount that companies will spend on broadband. So that's the main area we were looking at, was not whether or not the financial analysts were right or wrong. Which we absolutely know there are issues there.
Just very quickly, having tried to do budgeting forecasting from inside of major companies, it's always, we'd always try to look at a variety of different sources. It was never any one source, so it might, from a technology side, something from the advertiser, the folks who focus on the advertising marketplace, those who focus on the television marketplace, if that's your business, and it's kind of a consensus forecast that you're dealing with all the time.
2 minutes?
I don't have much material to add, and specifically about latency, I'm unaware of any regulations related to that.
Okay, so now we heard the panel. Now we're as educated as the panelists. I want to show of hands. Do you think that the networks will be able to handle the video traffic going forward? Yes or no? Who
By what
said
year?
yes?
By what year?
Well, let's say
By what year?
By 2015, 2016.
What percent?
Those that say no, I will experience a bubble.
What percent?
We're doing that neutrality.
What's the bottom?
In 4 years, are we going to be able to handle the traffic, yes or no?
Yes.
No, yes?
Yes.
No? Okay, well, that's.
Where?
That's a bottleneck. That's a bottleneck. I mean, so if the packets are a little bit slowed down, I mean, is that a catastrophe? It'll work.
No problem.
Okay.
Okay, next panel.
You guys gonna vote